Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat. But before we begin, I'd like to quickly review two items: our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. The session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our on-demand content. And if you have not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now, and if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in here our hosts, Rishab and Bruno, for our Twilio and Microsoft AI hacks. Hello. Welcome back.
Hey, hello everyone. Hello, Rishab.
Hey, Bruno. How are you?
Fine. And hey, thanks for the intro, Alexia. And hey, super happy for today because this is literally super out of my comfort zone. I haven't used LangChain in a long time. I've been doing a lot of semantic kernel, but I really like when we get to these sessions because not so far time ago, I had one friend doing a similar session using Java, and it was super nice to see the everything sounds like familiar. So I'm looking forward for this one, and also to see. I will encourage people. I see the list of names that we have of teams and more. I'm looking forward to our final session to see the presentations, ideas, and more. So, hey, this is going to be a fun one. I don't know, Rishab, are you excited? Let me show you the screen, by the way.
Yeah, definitely. So for people who are joining this session for the first time, this is part of the Twilio /RX Microsoft Reactor AI hack. We kicked it off 2 weeks ago in person at the Toronto Microsoft office. But all of these virtual sessions are helper sessions, so you're free to join them and learn about building AI applications. Last week we had Bruno presenting, and we do have some upcoming sessions. So build AI apps with LangChain is for today. And then we also have Bruno showcasing semantic kernel next week. Is that right, Bruno?
Yes, and I may bring some friends to help me because I've been talking a lot about that. And nice. It's always me, my face. So I want to bring some. What I'm going to do is, because we are also close to the end, I know a couple of friends we have some very cool projects to show there. So I may ask them to basically talk about that. Like in example, one of these colleagues, they have a super nice theory why planners are not going to be part of any of these LangChain semantic kernel SDKs anymore because the models are becoming so powerful that they can plan. And next session, I will try to, of course, show code and so this, but also bring some real examples there. But this is for next week. This week, let's focus on semantic kernel. And as Rishab mentioned, and I think Alexia shared the links. Yes, Alexia, you can check the recording from today's sessions and the previous one. You can take a look at the links. We have a lot of links with all of the materials that we are talking about. Hello, Texas, and more. And hey, I'm looking forward for today. So I'm going to go back to you. I'm going to be in the back, taking a look at everything here, but it's all yours, Rishab.
Thank you, Bruno. Thank you. Yeah. So you can, if you are in the Toronto area and you would like to participate in this AI hack, I know this is a helper session showcasing LangChain, but if you're interested, the link will be shared in the chat, but it is aka.ms/msft Twilio AI hack collection 1. There is a link to register your team if you already have a team. If you're looking for a team, we have other teams' socials and information available, so you can reach out to them The only catch is you have to be in person for the closing ceremony, which is on September 26th. So this will be in Toronto at the Microsoft office, and we do have both cash prizes and some swag to be won. So yeah, check out the links that are being shared, and this is the aka.ms link that I was telling you about. Quick shout out to RagHack. So if you build something for this hackathon, it is probably going to qualify for the Rag Hackathon as well. So go check that out. You can search for RagHack Global Hack, and that one is virtual, right, Bruno?
That's the one is fully virtual. Yes, it's closed. I think we closed the end of this week, and we're thinking that it's going to be a good idea that if you are planning to do something and you have some idea already here, prepare for this Friday or Sunday. Can remember, you can go and also present it there. We also have some prizes there. That's a global one. But yeah, I'm still super amazed and super happy about the amount of things that we have here physically for Toronto. So yes, RagHack is plan B, and I will love if we have a winner here in Toronto that would also win the RagHack.
That would be awesome.
Brag a lot with my colleagues, bosses, friends, family, and more. The family won't care about this, but happy about that.
The local community. Okay, so since that's out of the way, I'm gonna get started on LangChain X Azure AI because I want to show you how you can build. I guess this will work for Rag Hackathon because we'll be covering Rag today. That's where Azure AI will be used today. Specifically, I'm gonna give a spoiler in the intro itself. It's gonna be Azure AI Search. But yeah, today we'll be learning about LangChain and see how we can build LLM-powered applications with using Azure AI Search. Awesome. Who am I? I'm Rishabh Kumar. I'm a staff developer evangelist at Twilio, ex Microsoft MVP. You can go on Twitter and find out. But I didn't get renewed for this year. Hopefully, I'll be back as an MVP for Azure. And I'll have a QR code at the end with all of my socials and stuff so that you can reach out if you have any questions regarding LangChain. So since we'll be building out an LLM-powered application, there are some requirements. So if you want to follow along, again, as the recording will be available, so you can follow along at your own pace later, you'll need Python. So the system should have Python installed. Anything version 3.9 or higher will work. You'll also need pip, which is the Python package manager, or any other Python package manager if you prefer something other than pip. You'll need a code editor. I'll be using VS Code because it's free. And also, you'll need an OpenAI account. This is optional. The reason why I say that is you can run your LLMs locally, especially the open source ones. In the kickoff or the opening session in Toronto, and also in the last session, we kind of showed how you can use Ollama to run Phi 3 or Google's open source large language models so that you don't need an OpenAI API key. And basically, you're using your own hardware to run the large language models, which means you don't have to pay, for the API calls to OpenAI's large language models. But in today's example, I'm going to use OpenAI. So what is LangChain? So LangChain is an open source framework that allows developers working with AI to combine large language models like GPT-4 with external sources of computation and data. And it focuses on composition and modularity. So it is open source, focuses on modularity, and it is available in Python and JavaScript. LangChain, so in simpler terms, LangChain allows you to build your own AI applications by combining the power of already existing large language models with your own knowledge or data. When it comes to LangChain, you can assume that there's a lot to unpack. But the key thing is new stuff is being added or modified frequently. Since it's open source, you yourself can contribute to the framework itself. So go check out LangChain on GitHub. But on a high level, this is what the framework looks like. So the first thing is models. So these are your large language models. It can be OpenAI, it can be Google, it can be any of the open source ones. The models are also known as LLM wrappers, allow us to connect to a large language model. Then we have prompt templates. So prompt templates allow us to set the instructions to guide the model's response. You might have heard about hacks on, prompt engineering, on how to get certain responses from ChatGPT, either on LinkedIn or X, or how to utilize Claude to its maximum ability by prompt engineering. So this is where that prompt engineering can be implemented within prompt templates. Then you have chain. So chains allow us to combine more of these components together. So let's say I want LLM GPT-4 to be combined with my prompt template. Chains will allow us to do that. We also have indexes that allow us to extract relevant information for the LLMs. In our case, this will be like the custom knowledge base that we want to extract certain documents or information to provide to the large language model. That's where indexes are used. And finally, we have the agents. So if you want your AI application to take action, right? So let's say you have third-party API integrations with maybe Expedia, and you want to book a vacation based on the AI application response it generated. You can do that with the help of agents. Now let's look at these components in action. So what I have here is, and let me know in the chat if the text is too small, but I believe it's good size. Anyways, I can increase it if it is not. So what I have here is I'm importing LangChain OpenAI specifically, their chat model from the LangChain library. And also I'm using a pip package called .env, which allows me to use the .env file. So my .env file has this OpenAI API key. This is just an example. I won't share my actual secrets. So again, all of this will be available on GitHub later, but here you'll paste in your OpenAI API key. And I'm loading that as environment variables. The other thing to note is the virtual environment. So I do have a virtual environment set up. If I look at the files, you can see .env is where all of the packages are installed already, specifically the LangChain OpenAI and .env. Now I can close this. So let's start by creating a function called ask_LLM. And it will take query as one of the parameters. This query will act as, the question you'll ask the LLM. So this is our function. Now, as you can see, I have a comment here saying initialize the large language model. And the way to do that is by just typing in LLM, since I'll be using the chat OpenAI. And that initializes our large language model. Now, I want to invoke the LLM. So let's do an invocation. And basically, it's the .invoke function. We'll pass in the query, which we have as the parameter in our function here. And we'll return this as response. Again, this is the Python implementation of LangChain. As I said, there's also JavaScript. LangChain is also available in JavaScript, so you can check that out if you are a JavaScript dev. Okay, so I have my function ready, very basic. So this covers our first concept within LangChain, which was the models or the LLM wrappers. Now I'm gonna print the response. So we'll ask the large language model here, and inside that we'll have our query saying, hey, can you provide me with some project idea for the AZ-104 certification? So if you don't know, Azure has a lot of certifications. These are cloud certifications, and AZ-104 is the Azure Administrator certification. I'm gonna hit Control S, and I'm basically asking OpenAI to provide me with a project idea for AZ-104 certification. So what I'm gonna do is Python starter.py is my file name. And if my API key works, we'll see a response from our OpenAI large language model. Okay. As you can see, we have the content saying certainly. Here are some project ideas for AZ-104 certification. Then we have the first project idea, which is setting up a virtual network in Azure. Create a virtual network in Azure with multiple subnets, security groups, and network security rules. Configure VPN gateways and express route. So it has some context that AZ-104 is an Azure certification, and it provided me with, a basic project idea that it thinks would cover AZ-104 skills. Awesome. Now, I want to take this a step further. As you can see, we have very generic response, and also we can clean this up. So we can clean how the response is generated so that it is like in Markdown, or if you want it in JSON, you can create an API where your AI application is an API that generates project ideas. But what I want to do is introduce the concept of RAG. So before we dive into RAG, I want to show you what vector stores are. So we know that these large language models, they are trained on unlabeled or unstructured data. And one of the most common ways to store and search over unstructured data is to embed it and store the resulting embedding as vectors. And then at query time, we can have the unstructured query to retrieve relevant vectors. So that is why we use vector stores or vector databases. So there are tools like Pinecone, VV8, or even Azure AI Search. So Azure AI Search will act as our vector store for today. And I'm gonna quickly show you that here in my Azure portal, I have the Azure AI Search LangChain, which is the AI search service. It has a URL, but it also has a connection string, which will allow me to connect to it. So let me quickly go over how I created my custom knowledge base. So in order to create a custom knowledge base, we also have to familiarize ourselves that we can't just pass the entire document. Let's say it's your internal knowledge base. In my case, this will be the study guides. So Azure 104, so AZ-104 has official study guide. If I search for this, there we go. And I just can't pass this entire text block. The reason is, when these are stored as vectors, this information will be passed along to our large language model. Our large language model has some limits. So you might have heard the word tokens. So, let's figure out what the GPT-4 mini token limit. So as you can see, it has 16,384 token limit. This doesn't specifically means characters. we can kind of see they'll give us an estimate of how many characters. Let's see if there is a comparison. I guess not, but there are tools available. So I know Tick Tokenizer, I think that's what it's called, where you can calculate roughly how many characters or words we'll have in the 16,000 token limit. That being said, since there are token limits, you just can't pass in huge documents, and that is why we'll have to create smaller chunks and store those smaller chunks as embeddings in our vector. Now, I'll show you how you can create those chunks. So I have another file called knowledgebase_pi. And here, the two things that have changed are the character text splitter import. So I'm using the text splitter from LangChain. Again, as I said, LangChain has most of the tools available if you're building your own AI application. Also, it has a URL unstructured loader. So if you have a URL, which in my case will be the AZ104 study guide right here, you can load the text from that URL. And I'll be using the character text splitter to create our chunks. So here I have basically 4 different certifications. So this is not just AZ104. It also includes AZ204, AZ305, and AZ400. Now, as you can see, I'm passing in the search endpoint. So this is Azure AI Search, which we just saw in the portal right here. I'm passing my vector store address and password. This will be used to connect to my Azure AI Search. And I'll be using the OpenAI embeddings. So there are different embeddings models that are available. I specifically like the OpenAI embeddings model, but you can use whatever your preferred embedding model is. So that is why here you can see that I'm also importing the AI embeddings model, OpenAI embeddings model on top. Now, this allows me to connect to the Azure AI Search. So the index name, as we know, is LangChain Vector Demo. And we also have our unstructured URL loader being utilized here. So what I'm doing is I'm using the loader and I'm loading all of the URLs. Then I'm using the character text splitter and I'm specifically mentioning the chunk size to be 2000 and the chunk overlap to be 200. So the chunk size means that it'll have 2000 characters. Chunk overlap means that so this is our one big document. It'll create, let's say it created 2 chunks of 2000. The last 200 characters will overlap, which helps us not losing context between different documents when they are passed to our large language model. Again, there are many knowledge or information. There's more information available on the chunking strategy. You can read about that more. And it is improving, especially as our token limits are increasing with bigger models. But I remember with GPT-3, it was an issue because there's only a bunch of context that you can pass. There was a hard limit on how much context you can pass. And then I'm using the add documents function and adding those docs into our vector store. So if I go in here, let's see if I can view our vector store. So here you can see the quota is 50 MB and I'm currently using 11.96. These are from the docs that I just passed to it. And if we go back, what we can do now is perform a similarity search. So there are different types of search you can do on your vector store. I'm going to be showcasing similarity search today, but you can look up into similarity search. There's also similarity search with score and also hybrid search. But basically, I'm searching for Azure Administrator, and the K value is the number of docs that will be returned. So there will be 3 docs that will be returned from my vector store where it's able to find the Azure Administrator. And then basically I'm joining all 3 of those docs as one. Now, at the end, I am doing a print statement of those docs. So I'm going to open my terminal here. This time I'm going to run knowledgebase.py, and hopefully we should get the similarity search results for Azure Administrator. Again, given that I had the Azure Search admin key and Azure Search endpoint stored in the .env file as secrets. So our terminal just returned a response, and you can see it is from the guide itself. But according to the similarity search, these are the 3 relevant docs that included Azure Administrator. So you can see this is the entire response. Now, what I want to do is, by having this vector store implemented, I can do the implementation of RAG. So let me quickly go over what RAG is. So RAG stands for Retrieval Augmented Generation, is the process of optimizing the output of a large language model so it references an authoritative knowledge base outside of its training data sources before the large language model generates a response. So I have no clue if GPT-4o Mini or GPT-4o was trained on the study guides from Microsoft. And this kind of pipeline with RAG can be used with your own custom knowledge base. So like, let's say you have internal docs, right, that I'm pretty sure OpenAI or Google doesn't have access to. Hence, these large language models were not trained on it. But you want these large language models to generate a response using that knowledge base or those docs that are internal within the company. You can do that with the help of RAG. So RAG extends the already powerful capabilities of LLMs to specific domains or an organization's internal knowledge base, all without the need to retrain these models. Again, the machine that I have, even though it's very powerful, I don't have the capability to train my own AI models. So RAG really helps me there. And this basically allows you to build this general kind of pipeline. So what will happen now is, in my example, we'll have a user. It asks us, hey, can you give me an AZ-104 certification project? Maybe they're preparing for that certification. What will happen is, since it's AZ-104, that query will be passed to the similarity search, which in our case is the Azure AI Search vector store. Azure AI Search will return relevant documents, and that will be passed to our large language model, along with the query from the user saying, hey, I need AZ-104 projects. Now the LLM will have not only the user query, but also the certification guide of AZ-104. Hence, it will be able to provide a more informational answer based on the official study guide. So this entire pipeline is basically RAG. Now let's take a look at it in action. So we already looked at knowledgebase.py. I can close this terminal for now. And what is happening here is I have another file called ai.py, and I'm gonna sip water because I've been talking for so long. But on the top, we have a bunch of inputs. So in our starter.py, we just had our LLM and we were passing a query to that LLM. Here, I also want to use prompt templates. And if you remember, that was the second concept in the slides. We are also gonna be using our Azure AI Search because that's where our study guide is. And we'll use, again, the OpenAI embeddings and also the OpenAI large language model. So what I've done is from our knowledge base, I've copied this bit, which is basically the connection to our vector store right here. And I have a function called project idea, which takes in two arguments. One is the certification, and then the other one is the level itself. So the first thing, let's initiate the LLM. So this will cover our first concept. So I'm going to use OpenAI. The second concept is prompt template. So I'll save that as prompt, or we can also call it template. Then we'll initialize our prompt template. Now here you can apply some of your prompt engineering skills, right? So for now, I'll leave this as blank and get rid of the quotes. But we need to retrieve the certification guide, right? So what I'll do is I'll do a similarity search. So I can copy this from the knowledgebase.py right here. I also copy this, the join statement. So within our function, we have docs, which will do a similarity search based on the query, not Azure Administrator. We don't want to hard code this. So this will be certification because we have certification as the parameter in our function or argument within our function. So query is equal to certification, and K, you can set this to whatever model you're using. So if you're using a bigger model, you can return more docs. But if you're using a smaller model, you'll have to, keep in mind the token limit. Okay, so now that we have our the certification guide, we can pass that in our prompt template. And I have a prompt template already here. So let me just copy because I created this by testing a few things. And let me paste that in here. So this will act as our template. And we can have the Python comments here. There we go. And I can quickly go over what this is. So the prompt template goes, you're a helpful cloud instructor that provides cloud project ideas about Microsoft Azure certifications based on the certification guide. Give me a project idea for certification. And this is where the user will select the certification of the level. So I'm also allowing the user to pick a level by searching the following certification guide. And we are passing in the docs that we got in return of the similarity search. Only use the factual information from the guide to provide the project idea. If you feel like you don't have enough information to answer the question, say I don't know. Your answers should be verbose and detailed, include a project name, project description, list of services used, and steps to make the project. Make sure your response is in markdown format like this. So not only I'm handling the RAG part of it, but I'm also structuring the response from the LLM. The only thing missing is now the input variables because the prompt template doesn't know what certification level or docs are. So we will add the input variables like such within our prompt template. Again, all of this is available on the LangChain documentation, but within our prompt template, now we have input variables. So those are certification, level, and docs, which are utilized over here. Awesome. Now, what we can do is create a chain out of this. So that is where the third concept from our slides come in. So chain, and it's pretty easy. You can just pipe the both components, so the LLM and the template. Sorry, I hit my mic. So LLM pipe template, or I think it's template pipe LLM. Let's go. I'm not sure if the order matters, but we'll find out. So there we go. And now we can save this into a response. So response is equal to, instead of invoking the LLM like we did in starter.py, we'll be doing a chain invocation. So chain.invoke. And now here we can map the arguments from our function. So this is our Python function. We can map these arguments to our input variables. And the way to do that is within curly brackets, you have certification. And as you can see, GitHub Copilot is taking over. So have that in there. We don't need to pass in docs because we don't have docs in our function, in our Python function. Now we are getting an error for embeddings. Let me see if I initiated embeddings. No. So let me do that right after we load the environment variables. So embeddings is equal to OpenAI embeddings. Awesome. And we'll return the response at the bottom. Okay, so our RAG pipeline is kind of built. We are using our Azure AI search. We are using the similarity search specifically to get relevant certification guide for whatever the user picks. We are passing all of that information using prompt template to our LLM, and then we are generating a response by using a chain. So here's a quick Streamlit app. So if you don't know Streamlit, Streamlit allows you to prototype web applications using Python. As you can see, I'm importing Streamlit as ST, and all I have to give the title to a web page is do st.title. I named this Cloud Homework. I have few select boxes. So first of them is certification. So the user can select AZ104, 204, 305, and 400, and also a level. So beginner, intermediate, advanced. If certification and level have been selected, I want to generate a response which will use my ai.py file with the project idea. So project_idea, and will pass along the certification and the level itself. And then it saves that as markdown on the web page. I think my headphones just died, but let me open my terminal here and do Streamlit run streamlit.py. Okay, that doesn't look right. Streamlit run streamlit.py. Again, I have Streamlit installed in my virtual environment. There is a requirements.txt file which has all of the requirement or pip packages in that file. So I'm gonna do Streamlit run, and we'll get a localhost 8501. So let me open that up in my browser here. So let's go here, go into my browser. Let's go with AZ104 and a project level beginner. Let me zoom in a little bit. And there we go. We have a project named Azure Resource Optimization. The project description is this project aims to optimize the resources used in an Azure environment to reduce cost and improve efficiency, which is one of the key objectives of AZ-104. And you can also see it has services used. So Azure Cost Management plus Billing, Azure Advisor, Azure Monitor, and Azure Automation. And also has steps to build this project. So you get the idea. We can try one more for AZ-204. Let's make it intermediate level, and you can see it's running. I don't know if I have, oh yes. So I have it printing in the terminal as well. So you can see it here. So this is what the project is for AZ-204. So this one is for Resource Monitoring Dashboard. It uses Azure Monitor, Log Analytics, and Azure Dashboards. Maybe try the DevOps one. So AZ-400 is the DevOps Engineer Expert. And you can see that it created a project for Azure DevOps Pipeline. So it uses Azure DevOps and Azure App Service, and it has the following steps. So I feel pretty confident about my AI application that I have built here. So this is the file itself. And I do see a lot of comments saying, would there be a sample repo? Yes, there is. So let me go to my GitHub. Again, this will be available in the chat too.
Yes, if you want to share it internally in the chat, please I can add it to the collection so that people have the full there, and it's also available for later.
Yes, I can do that. I just shared the link, and let me open YouTube.
Perfect. So let me share the link, and I will put it in the collection right
now. But yeah, so this is where all the code is available. Also, you can run this as an Azure container app. So I do have a Docker file, which you can deploy to Azure Container Apps if you want to make this public or want to use bits of the code here to build your own RAG application. But yeah, that was my project called Cloud Homework. It uses OpenAI large language model and Azure AI Search as vector store. Basically, this diagram. Again, I'm Rishabh, and you can find me on bento.me/rishabhincloud. It'll have all of the links to my socials, but I also have this neat QR code that you can scan. It'll take to exactly this link. But I hope you learned something new with LangChain, and let's address some of the comments if we have few minutes here.
Yeah, sure. Can you hear me?
Yeah, I can.
Perfect. So I added your repo to the main collection, so everything should be available here, aka.ms/mft Twilio AI hack collection. I know, long one, but you can just click there and it's going to show. And we have a couple of questions. First, a lot of people looking for the code, which is amazing. And I like this one about the LangChains for GAs. So is the implementation the same version? I don't know how much do you know about the JavaScript version.
I don't know much, but let's find out. The main concepts are the same. So you'll still have LM wrappers. You'll still have indexes, yes. And you also have the chain itself and the prompt template. All of that works same. It's just that the code will look different. Unfortunately, I don't have the same implementation in JavaScript. Maybe I should work on that if there are people looking for that. But if you look at tutorials, if you go to LangChain or just type in JavaScript LangChain, you'll come to the homepage for GS LangChain. If you click on tutorials, they have a lot of tutorials already covered, so you can see how you can build a conversational RAG application.
Oh, that's cool.
Yeah, so it has all of the JavaScript code, as you can see here. And there are a lot of other tutorials. You also have a build a local RAG application. You have a PDF ingestion and question answering system. So yeah, look at those. They have covered every use case or most of the common use cases, and I think it'll help you prototype your own AI application within JavaScript.
Hey, I like it. Thanks. As I said, I'm not a JavaScript expert, not also not a LangChain, but I was expecting something like this to have the basic ABC seem to be here for this. So hey, Venom, I hope this helps. And we have another one here from Andres. Said that for the ones who are starting any pre-component to install library, prerequisites, pre-requirements, firsthand that you have not mentioned yet, I can, yes, go for you. I have a standard reply there, but if you want to share something there.
I think I will go to my first point that I mentioned in the beginning. If you don't want to use OpenAI, maybe this is your personal project. You don't have an API key from your work, or you don't have I don't know what is credits. You don't have credits for OpenAI. Sorry, I was looking for the right term. You can install Olama. I briefly shared an example during the kickoff in person. Let me find that out here for you. LangChain Olama. So it's called LangChain-Olama on my GitHub. And you can see that you are able to install large language models or small language models, depending what you pull. But if you want to use Phi 3, which is Microsoft small language model, you can basically install Olama on your machine and do Olama pull Phi 3. And then you can either clone this repository, or you can go to just main.py and copy this bit over. Here you can see that specifically here, instead of using OpenAI, we are using our locally running Olama model. So you'll not need an OpenAI API key, but the response might take some time to generate depending on how good of the resources are on your machine. So if it has a dedicated GPU, with, I don't know, 16 gigs of VRAM, you'll be good. It'll be fast enough. But if it is, a really old laptop, don't expect to get responses quickly.
Yes, and my 2 cents also there is that Olama has a huge library of models, and Phi 3, in example, there are different versions for each models. Like if you go for Llama 3.1, in example, you have the small one, 8 billion parameters, but yes, you can download the big one if you want. If you go up, sorry, a little, let's keep in Phi 3, or there is 2 versions here, the 3 billions and the 14 billions. If you don't have a powerful machine, and you don't need to have a powerful machine, do not go for the big model. The big model is going to kill you. I don't have the numbers in my head right now, but for the big one, you probably need to. You're going to use, if you don't have a GPU and use just CPU, you're probably going to use 40 gigabytes of your RAM just to set up the model after a couple of questions. So it's required, but it will work. What is nice about this is that it will be slow, but it will work, so you can give it a try. We basically strongly advise everyone to give it a try if you don't have OpenAI credits, Azure credits, or something like this. Yes, you can take a look here. The biggest one that you have there is the Zema 2.
Yeah. And basically, you can just do Olama run Phi 3, I believe. This will open a CLI to interact with your model, but you can use, LangChain. I believe you can. So next week, this is such an organic plug. Next week, there is semantic kernel session. you can use semantic kernel with your locally running models.
Yes.
So here you can see that it has given me a CLI to say, I don't know, tell me a joke about programming. So this is using my PC at the time. It says, I am an object-oriented programmer and try to organize my code, but now everything has gone to the method. And it has given me a note that humor can be subjective. This joke plays on the terminology of both programming methods and everyday language. So you get the idea.
And yes, but in example, if you go back to the library, sorry to ask of the, and you go for the Llama 3.1, you see here there that they have the big one. They have the 405. That's almost over 200 gigabytes. Do not do that locally unless you have a big GPU and you have everything run it. It's going to kill your machine. But yes, for non-standard tools, I will say to everyone, install Visual Studio Code, choose your programming language if you are comfortable with Python, JavaScript, or C# or whatever. Find a library, find an SDK that help, really help. I mean, you can do everything that we are showing right now with semantic kernel, LangChain, and more. You can code all of this. You can do your own HTTP request to a model or even load the model in memory. I will advise everyone to use LangChain or semantic kernel and then choose your own whatever, as Rishab mentioned. If you plan to do stuff locally, Llama is probably the easiest one. There is LM Studio. We have an AI Studio extension inside Visual Studio Code that can also help, but give it a try. And other tools that I think, I don't know, I will say go back again to choose your language, programming language first, and then rely on the power of LangChain, semantic kernel, or another framework to do this. Because you can do it by yourself, but it will require a lot of work. That said, there is someone there, we were talking, I can't remember if it was for this one or for the Rack Hack, that they created their own vector memory, whatever, and they want to show it. If you have that, welcome also to show this.
Yeah, definitely. And just wanted to, I guess, yeah, we'll include it in the collection link, but I do have a lot of samples. So this one in particular, it summarizes blog articles or articles in general by using, Ollama. So in this case, I'm using Mistral model, but you can use whatever model you want. And it sends a text message of that summary using the Twilio library. So a lot of examples available. Bruno has a lot of examples of semantic kernel, which he'll be sharing next week. But yeah, use this as like a pathway to build what you want to do for either the Toronto hackathon or the RAG hack that we shared in the beginning.
Yes, and we talked about a couple of ideas 2 weeks ago at the office, and I love those ideas in terms of there are day-to-day scenarios. So I won't share it here, but we talk about how we can improve meetings. And if you work and you have at least one coworker, you probably know the concept of meetings, and you probably have an idea, okay, how we can do this better or what we can do here and there. So also, you don't need to have, you don't think that you need to have a cutting edge whatever scenario. Working in day-to-day things, it's super useful. And we really want to see more about that. So I think that we are at the end of the hour. Yes, let me check the comments. If we missed something, we have Larry from Canada. Well, next week we are going to talk about semantic kernel. I think we have all of the questions answered.
Awesome.
So probably time to wrap up. And yes, sharing that next week, semantic kernel. We have 2 weeks until the 26th for the final presentations. Please go there. All of the links are for the registers, the supporting links and more are in the main collection. Join the online series. And I am missing something?
No, I think you covered it pretty good. Yeah, we covered the next week session, we covered the closing ceremony, we covered RAG hack, and we learned a few things about LangChain.
Yes, and hey, yes, I forgot this, and then Alexia is not going to be happy with me. Please give us some feedback. You have there the link for the sessions. Let us know what can we do better next time, what other topics you want to see here. And also, please, if you want, also join the community of the Reactor. We are in X, formerly known as Twitter. I will keep saying Twitter. They are, or in Facebook, YouTube, and there are a lot of channels. The Reactor is there. Join the community and know about the future events and more. So thanks a lot, and see you this week. And hey, last minute question: how we can access this recording? This is going to be available in the in the Reactor YouTube channel in the next 24, 48 hours. Literally 1 day or 2 days later is there. So you can add it there, and it's going to be the link in the main collection that we are sharing there. Is the link to all of the past events and the future one. So I think that's it. Thanks, Rishabh. See you next week. Thanks, Alexia. And goodbye, everyone.